All right. So in this video, I'm going to explain to you how to work with the geometric progression, and then we're going to look at an exam question together like we usually do. So let me first introduce the geometric progression to you. So in the arithmetic progression, we had something called the common difference. In the geometric progression, you have something called the common ratio. So basically, it's a number by which you're multiplying to get the next one. So let me show that to you. Let's say you have number 2. You multiply to 3, let's say. 2 times 3 is 6. 6 times 3 is 18. So what's happening here is we are multiplying by 3 as we move from left to right. We have something called a common ratio. And the common ratio is obtained by taking a term un and dividing it by the term before it, so un minus 1. So here, if I do 6 divided by 2, I get 3. 6 is the second term and 2 is the first term. If I do the third term, which is 18, I divide by the second term, I still get 3. So we have a common ratio. All right? So in the arithmetic progression, we're subtracting. In the geometric progression, we're dividing, if you want to remember it like this. And the general term for a geometric progression is given by un is ar n minus 1, where r is the common ratio. Okay, and the a is the first term, just like the arithmetic progression. Okay, so a is the first term. And just like for the arithmetic progression, you can find sum, Sn, sum of first n term. It's a1 minus rn over 1 minus r, or a rn minus 1 divided by r minus 1. So here your r is less than 1 when using this formula. Here the r is more than 1. All right, and for the geometric progression, you can actually find sum to infinity in some cases. So sum to infinity is a over 1 minus r for modulus of r being less than 1, which is r being between minus 1 and 1. So if r is between minus 1 and 1, you can actually find the sum to infinity. In another video, we can actually go deeper into it, and I can show you how from the sum of the first n terms, from the Sn, I can actually get the sum to infinity, but that would be for another session, not for this one. In this session, I'm actually going to show you how we can actually use this amazing formula. I'm just going to erase this, and then we're going to look at an exam question together. Here we go. All right, so let's go to the desktop. Let me check this question. So this one was a question which was given in May 2022, AHL, so it's an actual paper, TZ2, and then number 7. All right, so let's look at the key information in the question. So the sum of an infinite geometric sequence is 9. So they're giving us the sum to infinity. So let me write it here. Sum to infinity is 9. And we go back. The first term is 4 more than the second term. Okay, so first term is a or u1. So let me write that. So the first term, so a is 4 more than the second term. So 4 plus u2. All right. So these are the two equations given to us. Now, for S infinity, we have a formula, which I wrote earlier. So I'm going to use that formula here. So a over 1 minus r is equal to 9. And this can actually be simplified. So 9 is 9 over 1. I can cross multiply. I get a is equal to 9, 1 minus r, which is 9 minus 9r. And then I can actually now use that a in the second equation. So 9 minus 9r is equal to 4 plus u2. Now, we have the general term, un is AR n minus 1, so u2 would be AR2 minus 1, which is just AR. So I can actually replace u2 by AR. And now I have another A, so I can actually replace the A here by 9 minus 9R again. So we end up getting 9 minus 9R equal to 4 plus 9R minus 9R squared. And I can actually send all the terms to the left. So I'm going to send the minus 9R squared to the left. I'm going to send the plus 9R to the left. I'm going to send the 4 to the left. And it will eventually give me 9R squared minus 9R, because this 9R goes here. There was another minus 9R, stays here. There was a 9 on the left. I move the 4 to the left, minus 4. So I end up getting a quadratic equation, 9R squared minus 18R plus 5 equals 0. I need to factorize this equation. If you remember the triangle method, I actually take these coefficients and I form a triangle, and then 9 factors of 9 are 3, and 3 factors of 5 I'm going to write as minus 1 and minus 5, so that when I cross multiply and I add, I should get the middle number. So minus 15 minus 3 is minus 18. So my factorization works. And I read in a horizontal way, so it's 3R minus 1, 3R minus 5. So I get R is equal to 1/3 and R is equal to 5/3. However, we don't have two answers here, we have one, because for sum to infinity to exist, the R has to be between minus 1 and 1. So we'll have to pick this one. This one gets rejected because it's not in the range between minus 1 and 1. Okay, not in range. So R happens to be 1/3. Then in the question we had to find the third term, so U3 will be AR3 minus 1, so it's AR squared. The first term, we need to find it. So the first term is A, which is 9 minus 9R, so A will be 9 minus 9R. The R is 1/3. 3 goes into 9 3 times. 9 minus 3 is 6. So it's 6 multiplied by R is 1/3 to the square. So it's 6 multiplied to 1/9, which is 2/3. All right, so here we go. That's how we solve the equation. So the key stages are always the same. We read the question carefully. We locate the key information. We write down the key information. So here the two key information were sum to infinity is 9. And the first term is 4 more than the second term. So I wrote these two equations, and then I used the formula to replace and build on these two equations. And you always end up getting two equations which you need to solve simultaneously. This is what happens in most of the exam questions.